All right, so in this video, we are going to convert from exponent to radical form and back. And then we are also going to be talking about just simplifying exponentials so we can kind of eventually start to move into our next topic, which is exponentials and then to logarithms. So kind of how do square roots and radicals work with exponential functions and vice versa. So go ahead and pause the video and try the warm-up where you are simplifying the radicals. So we're going to be doing the radical jail, or you might have learned how to pull it out with perfect squares. But go ahead and simplify these radicals. When I say simplify, I do not want decimals. Okay, just simplify them for me. So go ahead, pause the video and try this warm-up. Okay, so if I go ahead and try this first problem here. Okay, let's see, 45, I could do 9 and 5, and 3 and 3. So we put them all in radical jail. We pair them up for a perfect square, escaping death. So this simplifies to 3 square root 5. Okay, 675, I could do 5 and 135, so he's a dead end. I could do 5 and 27, so he's a dead end. 9 and 3, 3 and 3. So if I put them all in my jail, I've got 2 5s and 3 3s. So pair them up. Remember, they only pair as twins. Escapee death, escapee death. So I have a 5 and a 3 that escaped, a 3 that's left. So remember, if you have multiple things that escape or multiple things that stay in, you multiply. So 15 square root 3 is number 2. Okay, 225 is a perfect square, so our answer is going to end up being 15. But if we go through our whole process, we could use 5 and 45, 9 and 5, 3 and 3. So I would have 3, 3, 5, and 5. Pair them up, escape me, death, death. So I would have 5 times 3, which would give me the 15. Okay, go ahead and break this to 5 and 4, 2 and 2. So 5, 2, 2, and then I have 2 x's, 3 y's, because remember, we can pair variables the exact same way we can pair numbers. So I'm going to pair, escapee death, escapee death, escapee death. So I have a 2, an x, and a y that came out. I have a 5 and a y left. Okay, so just that's how we are simplifying our square roots. So we might be simplifying in square roots in this. What we're going to learn is how to convert from radical to exponential and back. So if a to the x is equal to the 4th root of a cubed, then by definition, a to the x times a to the x times a to the x times a to the x is a cubed. Okay, by adding the exponents, a to the 4x is equal to a cubed, so x is equal to 3/4. Okay, so basically, when we have this, you have it as, I like to call it emergency rule. So exponent over radical. Okay, so emergency rule, ER. So this is kind of what our exponent is going to stand for, and this is what our radical is going to stand for. All right, so when we're converting back and forth to its exponential form, so with its exponent, it's going to be E over R. So this first one here, 64, it has an exponent of 1. So I'm going to write the base, okay, and then I'm going to write his exponent over his radical. Okay, so 36 here has an exponent of 1, and this is a square root. So if you think of a square, we're just squaring to get rid of it. There's actually an imaginary 2 that sits in there that we don't see, so that we can write it into exponential form. So I'm going to write my base, exponent over radical. Okay, my next one, exponent of 1 again. So exponent over radical. So notice these are tiny exponents. Please don't do 16 times 1/4. Okay, my next one here, exponent over radical. Okay, my next one here, I'm going to separate it so I have x to 2 over 4, y to 8 over 4, and z to 3 over 4. And then I'm going to simplify within that. So I can simplify 2 over 4 to get 1/2. 8 over 4, I can get 2, and z is his simplified form. Okay, we can also work backwards. So when working backwards, we're going into radical form. So I put my E and my R, so then I write it 216 exponent radical. Okay, the other way that you can write it is with the exponent on the outside, and it means technically the same thing. Okay, so here's my next one, exponent radical. So x to the first, there's my radical, or you could write 6 root of x to the first, means the same thing. So if you want to go ahead and try the next one on your own, go ahead and pause the video and try the next one. Okay, so our next one here, we've got our exponent radical, so x squared fifth root, or if you want to write it with the squared on the outside. The other thing I want us to start checking with solid numbers like the 216 is, can we actually take the cube root of it? Just so that we can practice getting ready for things that are able to be simplified, like cube root of 8, square root of 16. So I'm going to throw up on my board here my graphing calculator so that we can try taking the cube root of 216 just to make sure it's not pretty and can't simplify. So when we're doing the cube root, we have to, I'm going to show you guys the one that you can do any type of root. So I'm going to press the 3 first. I'm going to go to the math. Yes, there is a cube root, but I want us to start practicing number 5 where it's any type of root. So I'm going to use that, and then it was of 216. Okay, because I can simplify that answer to 6, which means actually if I cubed 6, I would get to 216. Okay, so when we are doing numbers, we're going to see if we can actually simplify them. All right, so my next one here, we're taking a little trip back to IM9 or IM1. To get rid of that negative exponent, you could write it with a negative exponent on the outside. I don't like having negative exponents at all because that is generally a rule in math. So you have to flip them to the opposite side of the fraction, which we're going to go over in the next page, all of our exponent rules. Okay, so I'm actually going to drop him to the bottom of my fraction, and I'm going to make him a positive 3/4. Then I can actually convert him to his exponent and radical. So his exponent is 3, his radical is 4. Yes, we generally don't like square roots being in the bottom of the fractions, but for this sake, we're just going to go ahead and leave it there. Okay, the next one here, square root of 16. What I would prefer you guys to do is realize the square root of 16 is 4. Okay, we can do our square roots pretty easily, so we're going to do that to the 4th power. We're going to convert the x to the 6th. So I'm going to show you guys how that 16 converts still. So this is a little 2 here, remember. His exponent is a 1. So 16 to the 1/2 and x to the 6/2. Okay, you can actually type in 16 to the 1/2. So, 16 to the 1/2, and it should still give me 4, which is why this is working. Okay, so we got 4, and then I'm going to simplify. 6 divided by 2 is 3. Okay, so I've got my negative 8. This has an exponent of 1. Remember, there's a little 2 out there that we don't see. B to the 3/2. I cannot take the square root of 8, so that is my final answer. Okay, another way that you could write this is negative 8 to the first, b cubed, all to the 1/2, because technically that 1/2 would then be distributed to both of them. So we are going to talk about power to a power in a little bit. So just realize they can be written in different forms like that. Okay, my next one here, imaginary 2. Go ahead and try the next 2. Pause the video, try the next 2, see if you can set them up and simplify them. Okay, so this is D 3/2 and F 4/2. So this could be written as 2. Okay. You could have also done it all to the 1/2 power. This is H 4/2, J 6/2, so H squared, J cubed. Okay, our next ones here, we're going to be simplifying quite a bit more. So I'm going to put that 2 out there. I automatically know the square root of 25 is 5, so I'm not even going to worry about changing him to the 25 to 1/2. I'm just going to write him as 5 and convert all the other ones. So A to the 2/2, B to the 8/2, and C to the 10/2. So this is going to be 1, 4, and 5. Okay, my next one here, I've got 81, the next one on a 1, so then 1/4. X to the 5/4 and 12/4. over 4. So I'm going to just double check 81 to 1/4. So is there anything that when I take it to the 4th power gets me to 81? So 81 to the 1/4. It is 3. So I'm going to simplify him to 3. And this one to 3 as well. 12 divided by 4. All right, this one here, square roots and square roots actually cancel each other. X plus 3. Okay, another way that you could look at that, if we wanted to, okay, x plus 3, exponent over radical. So x plus 3, all to the 1st power, which is just x plus 3. Okay, same with this one, x plus 3, exponent over radical. X plus 3 is going to be cubed, or written out 3 different times. Okay, put a little 2 out here. We're going to go ahead and convert. So m to the 4 over 2, n to the 6 over 2. So m squared over n cubed. Okay, now based on that, go ahead and try your cube root one, because it's going to be very similar. Okay, so I've got 12 over 3, okay, 3 over 3, so j to the 4th, k to the 1st. Or you can have all of it to the 1/3 power. Okay, so our exponent rule. So this is our trip back to I am 9, I am 1. So when you multiply things with the same base, you add their exponent. So notice the 8 are the same. Okay, so when you multiply things with the same base, you keep the base. You do not multiply the bases. You just take 1/3 plus 2/3, which is 1. Okay, power to a power, you multiply. So 4 times a half, it's kind of like distributing into it. Half of 4 is 2. Fine. Same thing with this one. If you have multiple things on the inside, we throw some 1s on there, so I have the 1/2 to go to. So 4 to the 1/2 times 5 to the 1/2. Because 1/2 times 1 and 1/2 times 1. Okay, same thing with this one. We distribute it in. 4 to the 0 times 5 to the 0, but anything to the 0 power is 1. Our last rule that we learned from I am 9 was anything to the negative exponent gets dropped. So this little 3 does not have one, but I can drop that 7 squared, and 7 squared, 7 times 7 is 49. So notice the exponent becomes positive. I don't change the sign of the number, it's just the exponent. Okay, so we're just going to practice a little bit of stuff from your freshman year here. So multiplying things with the same base, we're going to add those exponents. So I'm going to keep that same base, and I'm going to get 1. Another way you can look at it, if you convert this, this is the square root of 7 times the square root of 7. Because they're the same radicals, I can multiply. 7 times 7 is 49. The square root of 49 is 7, which is the same answer. Okay, our next one here, power to power, we're going to send this in. So this is going to get me, when you type in your calculator, 2 divided by 3 times -3. Make sure you put the fraction in parentheses so it understands that the 2 and the 3 are together. Okay, and then you should get -2, but we cannot have negative exponents, so we're going to drop them to the bottom. So basically what I'm checking for endgame, if it's fully simplified, is do I have one of each variable? Did I get rid of any 0 powers and negative exponents? Okay. So I'm going to send this guy in here. This is going to get me -4. We flip them to the opposite side to make them positive. Okay. I could send the 12 in first, or I could move that negative exponent. I prefer moving on the inside first before sending it in. So that's actually what I'm going to do. I'm going to bump him up to be with the x to the 4th in the top, so that he is a positive 3/4. I kind of like to work inside out. So how can I simplify the inside to then work the outside? Now I'm going to send this 12 in. So 12 times 1/4 is 3. Okay, and then my next one here should be 9. Okay, so this one here, I'm going to move. Okay, I I can actually combine those. Multiplying things at the same base, I add their exponents. Now I'm going to multiply. So that gets me -1, which then I now have to redrop. So the other one I didn't talk about in here was that I'm going to add in is when I divide things. Okay, when I divide things, I subtract their exponents. So I'm going to take them away, or you can cross them out top and bottom. Okay, so anytime you divide things with the same base, you subtract their exponents. Okay, I'm multiplying in between all of this. I'll put a little 1 on him so that I don't lose him. I'm going to do 5 times 4. It is multiplication between all of this. The coefficients I multiply. But when I do the exponents, it's like, how many total exponents do I see? Well, there's an 8 and a 5. So I have 13 A's. Or multiplying things with the same base, we add the exponent. There are a total of 5 B's. Okay, because if I literally list it out, the 5, the 1, the 4, 1, 2, 3, 4, 5, 6, 7, 8, B, 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 B. I can see how many total are actually there. Okay, my next one here. One way you could picture this one, the square means there are 2 sets of them. Okay, and -5 times -5 is 25. So here's the deal. When I bring this 2 in, it is -5 squared because it's really a -5 times a -5, which is positive 25. Most of you guys won't notice the fact that it is 2 -5s that you're multiplying together. All right. Now, do the same thing we did on the last page. How many total m's? There are 14. How many total n's? There are 16. Okay, or 7 times 2 gets me to the 14. 2 times 8 gets me to that 16th power. Okay, dividing things. If you literally covered this up and just looked at the numbers, 12 divided by -6 is -2. Just like in the last one we multiplied, on this one we just divide. So now I got to work on those x's. So dividing things with the same base, I subtract their exponents. So 6 minus 3 gets me 3. 9 minus 5 gets me 4. If you think about it, there are 6 x's on top, 3 x's on bottom. Cancel. You've got 3 left. Okay, it always goes with the bigger number. Okay, this I'm going to drop to make it positive. And then 2 to the 4th is like saying 2 times 2 times 2 times 2. 1 over 16. It's got to be on the bottom. And what happens when we have some things that are a little bit weirder numbers? Okay. So in this one, I can't multiply these because they're not the same base. All right, so what I'm actually going to do is I'm going to convert it. So exponent radical, exponent radical. So we're going to look at some of these in different ways. So this is 3 to the first, 4th root, and 27 to the first, 4th root. So I can actually multiply 3 times 27 and get the 4th root of 81. Okay, and then we, or you could say 81 to the 1/4. Okay, so notice we have that 3 times 27. We just don't normally multiply things that are different bases, which is why I converted it. You can't take x times y. We would prefer not to take 3 times 27. Okay, and then we're just going to double check to make sure. So you can take 81 to the 1/4 or the 4th root of 81. Okay, so that's the one form. The other form, if I press the 4, I go down to this one, and I type in 81. You can see that they're both 3. Okay, so my next one here, if I convert it, exponent radical, so we've got 4th root of 5 times the 4th root of 125. Okay, so 125 times 5, you're doing the 4th root of 625. So, or 625 to the 1/4, so 5. Okay, so if you want to pause the video and try the next sets here that are a little bit different, go ahead and try them. See if you can think of a method Then the bottom left one's a little bit trickier. Okay, so this one here, cube root of 3 times cube root of 9, so cube root of 27 should get 3. Okay, this is 4 to the 1/6 divided by 4 to the 1/3. When you are dividing things to the same base, you keep the base. You're going to be doing 1/6 minus 1/3 in your calculator, and then doing your math frac button. Okay, so that we can kind of see what it is. We don't want these in decimal, so 1/6 minus 1/3, press enter, do your math frac. I get negative 1/6, which we can't have negative exponents, so I'm going to drop them to the bottom. I already going to tell you 4 to the 1/6 power is not going to be a pretty number, so we're going to leave it like that. Okay, you could also, some teachers prefer if you were starting in radical form to end in radical form, so we could put it back in radical form. Okay, so this we got 6 times to the 1/4 and 6 to the 1/3. So multiplying things with the same base, I add their exponents. So 1/4 plus 1/3. So I'm going to do that in my calculator. 1 divided by 4 plus 1 divided by 3. Press my math frac. I got 6 to the 7/12. And then we're going to put it back in his radical form. So 6 to the 7 with the 12th root.